All right, mini review here. Let's discuss so far what we've talked about. There's a lot of new information. We've talked about ionic bonds, and ionic bonds are formed by the electrostatic attraction between cations, which are always going to be your metals in your periodic table, and anions, which are always going to be your nonmetals in the periodic table. So don't forget that all-important staircase in the periodic table. And these have very different electronegativities, okay? So vastly different electronegativities. All right, so that right there is the cliff note for section 7.1. Now, covalent bonds we've talked about, and we've talked about how they can form between atoms by sharing electrons to achieve a noble gas electron configuration. Okay, so they are formed between neutral atoms. Okay, neutral atoms. And these are nonmetals. Nonmetals, okay, so if you have two nonmetals in a formula, carbon and oxygen, hydrogen and oxygen, carbon and hydrogen, so on, those are all nonmetals. Those are going to be covalent compounds, okay? So anyways, they share electrons to achieve a noble gas electron configuration. Okay, examples of ionic compounds, I forgot to say a couple. Magnesium oxide, for example. Okay. Now, and metalloids. Okay, so don't forget that metalloids kind of have this intermediate character, and those are included in the covalent compounds, okay, or molecular compounds. Now, you do have things that are intermediate, okay, and so for example, if you have something like this, magnesium sulfate, okay, we know that magnesium sulfate is composed of a magnesium ion, and we've memorized that since it's in group 2, it has a charge of +2, and we've all memorized that sulfate is a polyatomic ion with a charge of -2, okay? So this substance is composed of a metal and several nonmetals, so this is definitely an ionic compound, okay? This is an ionic compound, and there's an ionic bond that holds the magnesium together to the sulfate, which is a polyatomic ion, okay? So that's the ionic bond. Now, within this polyatomic ions, you have covalent bonding that holds together the sulfur and the 4 oxygens, okay? Because in water, right, water somehow doesn't break up that sulfur from the 4 oxygens. The sulfur and the oxygen are really bonded very tightly together, and these are held together by covalent bonds, okay? And we'll look at that. Okay. So it's not tricky. I mean, you've got two nonmetals that are combined by covalent bonds, and you've got the metal magnesium combined with, nonmetals by ionic bonding. Okay, so it's possible to have both when you have polyatomic ions. That's something to think about. All right.